Let's discuss example 2.1, average and instantaneous velocity. A cheetah is crouched 20 meters to the east of an observer's vehicle, figure 2.6a. So this one. Okay. So this is the cheetah that is 20 meters away from the observer, the vehicle. At time t equals 0, the cheetah charges an antelope and begins to run along a straight line. During the first 2 seconds of the attack, the cheetah coordinate x varies with time according to the equation x equals 20 meters plus 5.0 meters per second squared times t squared. Letter A, find the displacement of cheetah between t1 equals 1.0 seconds and t2 equals 2.0 seconds. Letter B, find the average velocity during the same interval. Letter C, find the instantaneous velocity at time t equals 1, t1 equals 1.0 seconds by taking delta t 0.1 seconds, then delta t 0.01 seconds, then delta t equals 0.001 seconds. Letter D, derive the general expression for the instantaneous velocity as a function of time, and from it find instantaneous velocity at t equals 1.0 seconds and t equals 2.0 seconds. So, here's the vehicle. Okay. Here's the vehicle. Then 20 meters from the vehicle, you have the cheetah. Then, that is time 0. X equals 20 meters. So take note, x sub 0 doesn't mean that is 0 because our reference point is the vehicle. Okay. Then at time 1, that is 1 seconds, he travels this much. We don't know yet, but it has an equation here. You can compute for the x1. x1 is unknown. Then t2, 2 seconds. Okay. 2 seconds, we don't know yet, but we can compute it using the equation. Okay. 50 meters away, so we don't know yet. It doesn't matter yet, the 50 meters. Okay, let's solve the first problem. Find the displacement between 1 seconds to 2. So this one, we're going to find this displacement. Okay, delta x. Delta x is okay. So you have delta x, that is x2 minus x1. Okay, x1 and x2 we don't know, but we have the equation x equals 20 meters plus 50 meters per second squared multiplied by time squared. Okay, now at time 1, that is 1 second, what is your x1? We can compute the x1 by substituting the t1 in this equation. So you now have x1 equals 20 meters plus 50 meters per second squared times 1 second squared. So the second squared will be cancelled. Okay, that should be 5.0. Okay, 5.0. Sorry, 5.0. So x1 now it's 25 meters. Okay, so that is x1. Now for the x2, okay, for the x2, that is t2, 2 seconds. So just follow this formula, 20 meters plus 5.0 meters per second squared, then you have 2 squared. That is second squared, so cancel, the same. So you now have x2 equals 40 meters. So you have now x2 and x1. So the displacement from T1 to T2 would be x2, that is 40, minus x1, that is 25 meters. So you have the displacement that is equivalent to 15 meters. So that's the letter A. Okay. Now, find the average velocity, okay, of the same time interval. So what's the average velocity? For the average velocity, you have, as the equation again, B average, okay, or along x, delta x over delta t. Your delta x, we computed that one. This is the delta x, that is 15, okay, divided by t1 or t2. What's t2? That is 2, minus t1, that is 1. So your average velocity would be 15 meters per second. Okay, what's next? The next one is find the instantaneous velocity at time t equals 1 seconds by taking delta t 0.1. Okay, paano yun? Now, you have instantaneous velocity is actually limit, okay, as delta t approaches 0. So delta x over delta t. So anyway, so like this, v, the delta x is, what's the delta x? Okay. Now, the delta x is not this one anymore because it says in the problem, instantaneous velocity at t1, that is 1 second, then your delta t is 0.1 second. Let me check. It's 0.1 seconds. Okay, 0.1. So it should be 0.1. Okay. Now, your x1, we computed that already. That is 25 meters. Now your x1 plus 0.1 seconds, it's not this one. No, it's not this one because this is x2 at 2 seconds. We are looking at 1.1 seconds. So we will compute that one using the formula, this one. So you have 20 meters. Let's not write the 20 meters anymore. Plus 5 times 0.1 squared. So you will get an answer of, what's that? Let's compute na lang. So you have 20 plus 5 times 0.1 squared. So you have, it should be, tama ba? No, it's 1.1 because the delta is 0.1. So yan. So it should be 26.05. Okay? Now, that is the x1. Actually, that is the x1.1. It's 26.05 meters. So, there's a little bit of, that's the delta. You can solve the delta x now. So, delta x is 26.05 minus 25. Okay? And delta t is, of course, 0.1. Now, the velocity, you can call this instantaneous velocity, but it's not quite that accurate. So, you have 26.05 minus 25 divided by 0.1, that would now be, so minus 25 divided by 0.1, so that is 10.5 meters per second. Okay, now let's do the other one. The other one is 0.01. Okay, so your delta t is 0.01. So you could have now x 1.01, that is 20 plus 5 times 1.01 squared. Okay, so 20 plus 5 times 1.01 squared, oops, so that is 25.1005. Now the velocity, that is 25.1005 minus 25 divided by 0.01. So let's see. Minus 25 divided by 0.01. So you now have 10.05. So as you go approaches 0, this one nawawala yan. Kanina nandyan. So let's try to solve delta 0.001. Okay? 0.001, that would be x 1.001, 20 plus 5, 1.001 squared. Okay? That's the result. 20 plus 5 times 1.001. Then you now have 25.010005. Okay? So to get the average velocity, in this case this is now instantaneous because 0.001 is very small. So you have minus 25 divided by 0.01. Okay, you now have, oops, it should be 0.001. So let's just adjust 10.005. So see, 0.5, here's 0.5, 0.05, 0.005. If you go on and on, it will become, it approaches 10 meters per second. You could say that the instantaneous velocity at 1 second is 10. Okay, 10. So that's it for the letter C. Okay, letter D, you have to derive a general expression. So this is the easiest one. This is the use of your differential calculus. Again, there is no fancy about our differential calculus here. So it's just very easy. You have to derive the equation. So the instantaneous velocity, as we have learned, is v equals dx over dt. Okay. Now you have the equation x, that is 20 meters plus 5 meters per second squared. Then you have t. Okay. If you have the derivative of x is dx, the derivative of constant, this is just a unit, that is not a variable, is 0. Then the derivative of a constant plus this one there should be, it's ibababa mo to, that's 2 times 5, okay, times 5, then you have t. Okay, so you have, no, it's not t, it's t, then you have dt. So dx over dt, it's 10t. Okay, 10t. Now, this one is actually the instantaneous velocity. So to get the instantaneous velocity at 1 second, so you have 10 times 1. So you have 10 meters per second, which is actually the same as this one. Now, if you go to t, the instantaneous velocity at t equals 2.0, so that would mean that is 10 to, that is 20 meters per second. So as easy as that. So we now have solved for the instantaneous velocity at t equals 1.0 and t equals 2.0.